Welcome to a new conversation with Tom Campbell. If you're watching on Tom's platform, there's a link in the description box below for my channel. Enjoy the show. Welcome to the show, everyone. We are talking about the nature of reality. Is our universe a virtual reality? Something akin to a video game? Is consciousness the fundamental aspect of all that exists? Tom Campbell is with me. He's a scientist and a physicist, wrote a book, My Big Toe, in which he talks about experiences that he's had that leads him to believe that we live in a virtual reality. And he says that his simulated reality theory is backed by science and that we can logically conclude that we live in a computer simulation. He's here to talk with us about this today. And I hope, Tom, that I can manage some questions that you haven't already fielded a million times here. I've been looking forward to this conversation. And also, guys, there's a timestamp in the description box below that covers all of the topics that we talk about herein. Tom, thanks for joining me. These ideas are very important to me, as they are for you. How are you doing today?
I'm doing just fine, John. Thank you for the invitation. I think we're going to have a very good session.
Start us out with some background here, maybe a little bit about where you went to school, what you studied, what happened with Bob Monroe, and what brought you to ultimately write My Big Toe.
All right. Let me try to make this short. If you want more, you can always come back and ask for more, but I'm going to try to keep it short. And that is, I'm a physicist, graduate school, master's degree, worked on PhD, did not get the PhD. I left long into the PhD work. I'd already passed my qualifiers. I passed all the tests. I'd done everything I needed to do, and I did the research, and I finished a research paper and put it into publishable form and so on. So I basically did the PhD thing, but then I had to leave the university. It was just, I had to go. And I started my career as a physicist. I discovered that I could use my mind to find errors in my code that I was writing. This is when I was a graduate student. That opened up a whole new reality for me. I'm a scientist, and I found suddenly this ability. It just happened in a meditation that I was doing. So that changed my mind. I'm a scientist, so I want to model reality. And now I found there was this part of reality that was connected to my consciousness, my mind, my intent, that didn't have any material basis for it. So for me as a physicist, that just opened up another whole piece of reality that I wanted to understand, wanted to model. To skip a bunch of steps, I found out that Bob Monroe was not that far away from me. Bob Monroe is author of Journeys Out of the Body, Far Journeys, and Ultimate Journey. He was a man that just had out-of-bodies happen to him. He didn't want them. He was terrified when they first happened. He tried to make them stop. He went to a psychiatrist for help, but they just happened anyway. So he gave in and said, well, I'll just journal them and, see what's going on. Well, that journal of his turned out to be his book, Journeys Out of the Body. And it was basically just a diary, a journal. This is what I saw. This is what I heard. This is what I, smelled and felt. And he didn't try to say this is right or this is wrong or why or any theory behind it. It just was his experience. So I got a chance to go meet Bob Monroe. And when I did, I was wondering, is this guy just making it up, wanting to sell a lot of books, or is he real? And if he's real, is he kind of goofy? Is he spacey? Or just what? So I went out to meet him, and he was a really solid guy. He was intelligent. He was straightforward. He was not an engineer, but he had the personality of an engineer, very focused, very rational and logical. And he had just built a lab to study consciousness. And he didn't really know what to do with that lab just yet. He knew he had to do that. He wanted to study consciousness because he wanted to put this phenomena that he had experienced, and he had convinced himself that it wasn't just his imagination, because he could gather information, he could do things, he could make connections that were evidential that he couldn't have done, So it wasn't just that he had a lot of nightmares, and a lot of dreams, but he had a lot of things that were evidential. So when you get evidential material like that, then you want to study it. You want to see, what is it? What's going on? What's happening here? So he built this lab, and I got there right at the beginning and joined him with the idea that if he would teach me to experience the kind of things he experienced, that then I would work for free. I'd come out and be a physicist working in his lab. So that was kind of the deal that was made. Well, that worked out very well for me. Now, my attitude going in was, if this turned out to be a lot of hocus pocus and not really science, I wanted to do science because I had this thing with my mind being able to debug software. And I knew there was some other parts of reality that weren't just physical, weren't material. They were mental. They were consciousness-based somehow. But I didn't understand them and have any idea, why they worked. Why me? Why did it work for me? Why did it work for Bob? So I was starting at ground zero, and Bob was too, for that matter. He didn't really understand what had happened to him either. So myself and a friend of mine, Dennis Menrick, we both worked in technical intelligence at the time. We started to go out and talk to Bob, and Bob started to teach us, and we started to do experiments. We did all sorts of experiments. One of them turned out very well, which is we were trying to help other people experience the same things. And we found this idea of binaural beats. And a binaural beat is a technology that helps entrain brainwaves. So if you put a person up on an EEG, put all the electrodes all over their head and look at the EEG, and then if they listen to binaural beats, whatever that beat frequency is, their EEG energy, it's basically energy, frequency and how much energy in that frequency. Typical EEG is spread over a lot of frequencies, but what it would find is that more of the energy would start to accumulate in that frequency that was equal to the beat frequency in the binaural beats. So they called that brainwave entrainment. And that was a technology we played with a whole lot in trying to get naive subjects to see what they got out of this. We wanted to get past the idea of belief, that sort of thing. We mostly used naive subjects that had no idea what was going on and got them to go through some experiments with us. So they didn't have any preconceived notions or anything what was going on. So we used the binaural beats, and I did also a lot of research in the non-physical, because after a while, Bob taught me how to experience the things he experienced. And I did experience those sorts of things, and I could do it when I wanted to, and I could repeat it. In other words, I could get right back to that same altered state of consciousness very precisely. So, and that allowed me to actually do science there. In other words, we were doing things that were evidential. We were, doing remote viewing. What is at a certain place in the world, or here's a number I'm going to put on the blackboard after you guys get locked into your, isolation booths. What's that number? So we did just lots of things that would be evidential. And both Dennis and I, after 3 or 4 years working with Bob Monroe, had done hundreds, probably thousands of things that were very evidential. Something real was going on. It wasn't just we were having nice daydreams in the lab. So I started going into these states where I was doing things that were evidential and changing, say, one parameter. So you change it and then see how that changed the result. Did that change the evidence? Did that change the results of what was going on? Did it make it easier or harder to collect that evidence or to have that effect that we were trying to have? And then I'd change it a little more, and then I'd hold that constant and change another variable. And so on. That took a long time. So that was about 35 years worth. I wasn't all at the lab with Bob Monroe. The first decade was about Bob Monroe, but it was 35 years worth of basically using my consciousness as a lab to study consciousness, to study what could it do, what couldn't it do, to try to discern why couldn't it do it, or why it could. What were the parameters? What made a difference? What allowed you to be effective at collecting evidence that you were doing something that was evidential, real, not just something that could be in your imagination. So I did that for a long time. And after about 35 years of that research, I thought I had enough together to write a book. And of course, that's the My Big Toe books that you just held up and read. So that's basically, it took me about 5 years to write. And that's basically a summary of what I had learned through all of this trial and error, basically, work inside of consciousness. And what happened is that, in all that time, of course, I was working as a professional physicist, an applied physicist at the same time. So I kind of had dual careers going here. I had my day job, which was in physics, and my night job, which was in consciousness research. So that went on for a long, long time. And what I did is I had a bunch of facts, things that I had determined from my own experience were facts of consciousness. And of course, I had a set of facts about the material reality. As a physicist, I had those facts as well. So then I started looking for one overarching understanding that would derive both sets of facts. Not just support both sets of facts, but derive both sets of facts so that you could understand why the physical world was the way it was, its limitations, its mysteries, why the consciousness world was the way it was. So I was looking for this overall theory, if you will, or understanding is maybe the best, or model is probably the better word. I was looking for a model that would explain everything, the proverbial toe that scientists look for. But this was not a little toe. A little toe is the one Einstein was working on, and that was to make relativity and quantum mechanics, to find what was the superset of that, because those two were both successful, but each one had a kind of a philosophical concept that the other one denied. They're not really entirely compatible with their view of reality. So the scientists at the time realized that there's something else, some other bigger understanding that you should be able to then derive both of those from. So you had two separate things, and two separate things are fine, but they each work just in their own area, which means there's something bigger yet atop of those in the hierarchy of understanding reality. And that's what Einstein called a toe, a theory of everything. But just unifying quantum mechanics and relativity, I call that just a little toe, because that's just kind of an overview, an over-theory of the material world. Whereas I was looking for an overview of everything, including consciousness. So I come up with this idea and this theory, and then I published the books, which are pretty much theory of consciousness in the books. And then I realized a couple of years after I'd published the books, this is 2003, that, this is how quantum physics works. I got it. And then, this is why the speed of light's a constant. Well, those two things basically define all of modern physics. That's how we do physics these days. It's relativity and quantum mechanics. Those are the things. Classical mechanics, Newtonian physics, is just a subset of the quantum physics and of relativity too. So the classical physics just works in a space where things don't go too fast and they're not too small. But it's just that subset. So it's not the general model. So anyway, when I understood why quantum physics worked the way it did, quantum physics wasn't weird physics anymore. It was rational physics. And you take the old line that Feynman said that says, just shut up and calculate. Or he also said, we'll never understand in the normal way of the word understand, how quantum physics works. It's just something that nature's not going to reveal to us. And those things were just wrong. You don't have to shut up and calculate. You can look at the logic and tell what the result's going to be once you understand how it really works. So I started looking at other mysteries, that are in physics. So we call these paradoxes in physics. And there's a bunch of paradoxes in physics, lots of paradoxes in physics, things that just don't make sense from a materialist viewpoint. For the most part, they don't make sense. One of those things is, where did that ball of plasma come from that was the Big Bang? We know if we start with that ball of plasma, we can evolve all the rest of the universe. But where did that ball of plasma come from? Didn't come from this reality, because that reality hadn't existed yet. It didn't exist until that ball of plasma, expanded and created the suns and planets and so on. Oh, and then there's lots of smaller paradoxes, like where does time come from? Where does charge come from? Where does space come from? Where does mass come from? Physics really has no idea about those things. You ask physicists about all the basic things in physics. Physics is just the interrelation of all those things: time, space, mass, charge, spin. These are the basic quantities. And science has no idea where any of those things originated. How did they come to exist? They just are. Science says they just are because they are. They're a given. We start with them. Well, that's not very scientific. They just are because they are. You'd like to understand them better. And this overall theory of mine, which then I called my big toe because it was a big picture theory, that answered all those questions. Why the speed of light is a constant. Everything else, the speeds add. The velocities add. If you're in a car going 10 mile an hour and you reach out and you throw a baseball another 10 mile an hour in the forward direction of the car, the baseball is going 20 mile an hour relative to the ground. Well, it's not like that with light. You take a flashlight, and let it go, half the speed of light, and turn on the flashlight, and the light that comes out of that flashlight is still going just the speed of light. It's not going 1.5 times the speed of light. So it's an odd thing. And we have odd things like photons. Photons are particles, right? Yes, but what's their mass? Well, they have zero rest mass, but they have mass, which is really energy, because, the equivalence of mass and energy. So that's kind of an unusual sort of thing. What do you mean you have a thing that has zero rest mass? What does that really mean? So we're getting, it's kind of, that's not Newton's science. That's not Newton's physics. You see, physics is getting weird.
Let me make sure that I'm with you here. So you go to school, you study physics, you major in physics, you get out of school, you work in physics, you meet up with Bob Monroe, who is someone who started having these experiences kind of just unexpectedly, and he was trying to understand what was happening to him. So he sets up a research center. You come there, some other people come there, you do studies for years at this place, and over the years you kind of come to these certain realizations. This is a fact about reality, this is a fact, and you accumulate enough of these facts, and it leads you to write a book called My Big Toe. And we'll get into some of the specifics with the speed of light and the pixelation of reality and whatnot. But let's talk about consciousness for a moment. When you write this book, what kind of conclusions do you draw about consciousness? I think that'll open us up to some of these questions that I have for you here. Okay.
Well, I come to the realization, and it was actually during the process of writing the book, because once I found out that I started writing the book, I realized I had a lot of ideas that were kind of fuzzy. They were kind of foggy ideas. I thought I understood them, but when you have to actually write something down, it forces you to clarity. And there's lots of ideas. We normally don't mind fuzzy thoughts. We don't even know the thoughts are fuzzy. We think we just understand something. But when you have to sit down and write it down, then suddenly you realize that it's not all that clear. So it took me
You
a
know,
while
that's
to
so
come.
very true. And I want to jump in here because I just finished a book called The Power of Writing It Down. And what you said is so true about clarity. And if you have
Yeah,
to write something down, you actually have to think it through, which will lead you to more realizations. But that
exactly.
was just a great point. That's such a true
Yeah.
point about reading. But go on with the
Okay,
book.
so as I was writing this book, it became clearer and clearer to me that consciousness was about information. It was all about information. And that was, I mean, if I bring that up now, it's rather obvious. What are you conscious of? Well, what you're conscious of is, and you can describe that with information. So consciousness is awareness. What are you aware of? Well, that can be described with information. So consciousness is an information system. Okay, consciousness is a system. Now, I learned, one of the facts I learned is that doing this research is that consciousness is fundamental. And I got that point because I could work from consciousness, just from mind, from consciousness, and I could affect things here in this reality. But I could not do the opposite. I could not start from here and change anything that was fundamental in consciousnness. So the arrow of causality always went from consciousness to the physical world. And what
Can you
that
maybe
tells
give us an example of that? Just to make sure that I'm fully understanding your concept there with how you can affect the world with your mind, but it doesn't work in the reverse.
Okay, well, you can affect the world with your mind, and you can do that in many ways. Part of the ways that the consciousness works is that your intent can modify the future probability. Okay, now that probably
Right.
doesn't make any sense to people yet because we haven't discussed that, but this world is also information based, and it's not a bottoms up simulation. It's not where we start with particles and build up bigger particles and bigger particles until we finally get to molecules, and then we get to the physical world. It's not that. It's more of a top down done in probability. It's that sort of a model. So when you do a bottoms up, you know what's going to happen next because you've worked all the things that are in motion. What's going to happen next is that motion's just going to move a little bit, right? When you work from the top down, how do you know what's going to happen next? You see, you're not building it, you're just describing it. So when you go from the top down in probability, we have this, I have found, this is one of the things I discovered, is that the way the system knows what to render next is it takes a probability distribution of the possibilities, and it takes a random draw from that probability distribution. Now, a random draw doesn't just randomly take one out of the possibilities. It's a random draw from a probability distribution. So the things that are more probable are more likely to come out in that random draw. Okay, so that's how it knows what's going to happen next. So everything that happens next is always possible because it's taken from a random draw from a distribution of the possibilities. But some things are obviously more likely than others. And sometimes that's a 0 and 1. It's obvious only this can happen. But often there's many things that can happen. And we can modify those probabilities with our intent. That's what I meant by, so now I just skipped about 10 steps, and launched into something else, but just kind of pretend that might be true for a while.
Okay.
And because we can modify future probability, we can actually have an influence on the things that happen here. Because what happens here is drawn from that random draw from the probability distribution of the possibilities. So I can affect it. That's how people use their minds to heal. You've heard, no doubt, of people using their intentions in their minds to heal. Well, that's a real thing. You can do that. That's a thing that you have to do many, many times and keep statistics on. Like almost all of medical science, you have to look at the probabilities. You can't say, oh, here's a pill, and this pill cures headaches. And you give it to somebody and their headache goes away, and you say, proof. That's not proof. Their headache might have gone away anyway. You got to give it to 10,000 people, right, under all sorts of conditions with a good sample and so on. And then you can maybe say, this is significant. here's evidence, you see. So the evidence comes in the probability. So I did a lot of those sorts of things. We're using intent. I did remote viewing where I would see things that otherwise I would have no way of knowing, what was there. Numbers on boards, places on maps, places I'd never been, and things I wouldn't know about. And they were accurate, but not always accurate. So now you have to understand, well, why aren't they always accurate? Here in the physical world, you either see a brick or you don't see a brick. It's not like, well, I think I see a brick. But in the world of intuition and in the world of consciousness, it's about probability. It's not the same. It's not like you just take this physical world and move it into another space. It's not like that at all. It's a totally different thing, this concept of consciousness. So I was able to affect things, to remote view, to come up with information about maybe other people that I could check and see if it was true, and so on. And I could do that with consciousness, but there wasn't anything that I could do here that really affected consciousness. And you say, well, of course you can. Somebody hits you over the head with an iron pipe and that affects your consciousness. No, what it does is it sets more constraints on what consciousness can do with that body, with that avatar. Okay, so it's not that it affects consciousness, it just constrains consciousness. Or you can do things that lifts constraints. Let's consciousness maybe do more things with that body. So it just changes the constraints that the conscious has to work with. It doesn't actually change consciousness. So that was a conclusion I came through, and I'm just giving you just tips of the iceberg. I'm talking now about, hundreds and hundreds of experiments that I did over time, trying to determine, about what people experienced and what they did, people who were hurt, people had brain injuries, people who were comatose, and how was their consciousness affected by that? Well, how did I know that? Because eventually all consciousness, you see, is connected. Every consciousness is in a big net, if you will, just like the World Wide Web, where all the websites are on this big net, and any website can be gotten to from any other website. Well, consciousness is like that. Every conscious entity has a potential connection to every other conscious entity. So that person who was comatose or that person with the head injury, you could actually connect with them, consciousness to consciousness, and see what was going on. Now, yes, all of this is subjective. Okay, all of the things that are what we'll call paranormal, that are not explained with materialistic, viewpoint. All of these things that are paranormal all happen on the intuitive side. They don't happen on the intellectual side. Consciousness has two ways of processing information. One is intellectual, that uses logic. The other one is intuitive, that doesn't use logic. It uses something else. It's beyond logic. It's intuitive, but it's still real. Now, almost anything that we do very, very well, we have to do intuitively. There's very little that we do intellectually very, very well. Now, there's some exceptions to that, but let's just take the most obvious one is touch typing. When you touch type, if you use your intellect, where's the T? Oh, okay, there it is, top row, right there. Where's the E? Well, you're never going to type very well if you do that, if your intellect is looking at the keys. You have to get to the point where it's intuitive, where you don't think, where is that? Your finger just knows where it is without logic, without thinking. So a touch typist can be a really good typist. Any athlete who's at the top of their game, like Olympic class athletes, will tell you that, whether they win or lose is mostly their mental. Everybody's trained, everybody's fit, everybody's good at what they're doing, but winning is mental. You have to have the right mindset, and that's all intuitive. So that's just two different ways that the mind works. There is an intuitive side to it, and all the paranormal stuff is over on the intuitive side, and that is not objective. That's entirely subjective. So that's one thing about my big toe, my theory of everything, is that it describes and explains everything subjective as well as everything objective. Now, another point I'd like to make that it'd be important for your readers is I have this theory of everything, this big picture theory of everything. It's not to say that this is what I think must be true. It's not that this is what I believe. This is a model. I'm a scientist. This is a model. So I've made a model of reality that says, I have a couple of assumptions. One is that consciousness exists. Another was that evolution exists. That's it. After that, I logically describe this model. Now, what makes a model valuable isn't whether the majority of people like it, or whether they don't. What makes a model valuable is what can it explain. Okay, now there's a bunch of facts that are called experimental facts. These are the things that experiments show these are true. These things happen. Experimental facts. Now, remote viewing is one of those experimental facts. And you have to be really blind, to not be able to find that that's a fact. There are plenty of people who remote view and are very good at it. So if that's a fact, then there needs to be an explanation for it. There are people who have precognitive dreams. That's a fact, and how does that happen? Why is it? Is it just luck, just dumb luck that they do that? Well, there are people who can, help the law enforcement find criminals and, find things like that. These are things that are done. And they're facts enough that, of course, we had people that were helping the CIA find out, facts. And that was a very successful program, even though it either is still a successful program that nobody's talking about or it's been ended. It's hard to say. You'd have to have the right clearances to decide which one of those it was. But in any case, these are facts. So you need to deal with them as facts. So my model basically can explain all of the subjective side. Now that means it has to also explain to people like, why are you unhappy? Why are you struggling with life? So all of those things are subjective. What is love? All that's subjective. So it has to be able to explain all those things and explain them logically. So that's kind of the model. But no, this is not Tom Campbell's belief or the way he thinks the world is. This is a model that I've constructed based on my research and the data I've done. And it explains all of the physics. It explains all of the objective world better than the current physics does, because it explains quantum physics and relativity and solves a whole bunch of paradoxes. And it explains the subjective world better than we have now too. So it's just better science. And eventually this will become kind of well known, I think, in a dominant viewpoint of reality, because it just is better science. And given time, better science rises to the top. It always does. Even if it takes, a century to do that, it does. So this is not my belief. This is, a model. Judge the model solely by what can it explain and how many assumptions, what kind of contrivances does it need to explain it. So you need to explain, like Einstein said, the point of all science is to explain as much as possible with as few assumptions as possible.
So you come to this point where, after doing experiments and looking at, physics results and whatnot, that you come to think that we're in an actual computer simulation, that this is all some kind of program running out and we're simply avatars akin to what we would, think of as a computer. What specifically led you to think that this is a literal simulated reality, and how influential are the double slit experiment and the quantum eraser experiments? How do they play into your whole idea about the simulated reality?
Okay, well, the logic went something like this: a realization that consciousness is an information system. A realization, and this is again a fact of mine. When I call it a fact of mine, let me point out that if it's not your experience, it's not your truth. These things that I'm saying are my truths because they're based on my experience. And I don't expect them to be your truth or anybody else's truth unless you experience them. but you can experience them, and we can talk about that later. But in any case, so we have consciousness is an information system. Consciousness is fundamental. Those were two things that are my truths. If it's fundamental, that means everything else is derived thereof, so it's the source. So then how does bricks and elephants and, garbage trucks and all the material world, how does all that stuff get derived out of consciousness? That's kind of a bizarre thing. Well, you also realize that consciousness not only is fundamental, but it is the fundamental substrate for everything. It is the fundamental source, if you will. Now, I call it the larger consciousness system, but that's just a metaphor for source. It's the thing at the root, at the bottom, the foundation of everything else. And I found that the way I could change things and manipulate things in the physical world, like I was saying with mind, I realized that the physical world is derived. Well, that's easy to see. Okay, we have quantum physics and particle scientists, particle physicists telling us that reality is information-based. And if you go to any physics department and look up the quantum theorists and the particle physicists, they'll all tell you that, yes, reality is information-based. It's not physical-based. It's not matter-based. They can't model an electron as a chunk of matter with a chunk of mass with charge. They can't get the right answer with that. It doesn't work. That's not reality. They have to model an electron as a point with the attributes of mass and the attributes of charge, which is the way you would simulate an electron. That's how they can use their quantum physics to calculate what happens when atom smashers over in Geneva, blow things apart and get lots of particles out and energy out. They have to model it as point with attributes, not as little chunks of mass. So the scientists today, modern scientists, I think, are pretty much in agreement that our reality is information-based, but they don't know what to do with that. They don't know what the next step is. They don't know how to, they don't know how to write that down in an equation. They don't know how to put that in any way that's coherent. So they're just stuck there, and they just say that. They're not necessarily going to say it's a virtual reality, but because they don't necessarily want to go there.
Yeah.
But they'll say it's information-based. So when I put all that together and I understood this thing about the way the system works is it's probabilistic. Well, quantum physics tells us that too. Particles are only potential particles. They're only metaparticles until the measurement's made. And then that magic happens when the wave function, that's a probability wave, function collapses to a physical measurement. Well, that sounds kind of mystical to me. Wave function collapses to a physical particle, and there are no physical particles until that happens. The particles are all just proto-particles someplace, potential particles. Well, that's telling you something about our reality. So quantum physics gives us, delayed erasure, is another one of those things, whereas you already have the particles have made their imprint on the screen. And afterwards, delayed, that's what the delayed mean. After that happens, you change something. And you find out that what's on the screen will then turn out to support what you changed it to. And it looks like it's gone back in time and rearranged itself. Well, It doesn't do that. It doesn't go back in time and rearrange itself. It just looks like that when you don't understand what's going on. So anyway, kind of getting off the subject here, but this is a model that then explains all that stuff. The larger consciousness system is the source system. It works on probability. Quantum physics tells us that probability is at the core of this, not matter. And after that, it's easy to realize that, one, we are conscious. We are consciousness. So John Michael is consciousness. He's a piece of consciousness. And what is this physical body? Well, consciousness can manipulate the physical. So what is this physical body? The physical body is the avatar.
Mm-hmm.
And then I started looking at games, simulated games, simulated realities like World of Warcraft, like The Sims, those sorts of things.
Yeah.
And you look at how it is they're structured. They have a program, right, is written. That program is written, and the computer takes that program and it calculates everything that's going on. Now, those things are all in 3D. They're not just stick figures walking around in 2D. They were in the beginning, like, what was it? Some of the early 60s and 70s, games were
Right.
all just 2D.
Mm-hmm.
But eventually you get perspective, you get 3D, you get all of that's going on. So what's happening there is that if we make an analogy between us and the computer game, if you look at the elf that's in World of Warcraft, that elf
Mm-hmm.
cannot find the server that's serving the program. That elf can't find it because that server has to be outside of that virtual reality. The elf can only run around inside the virtual reality. So the computer has to be non-physical from the elf's viewpoint. All right. Now, also, from the elf's viewpoint, the player has to be non-physical too. The player is the one that makes all the choices for the elf. What's the elf? The elf is just some eye candy that lets us keep track of what's going on, something that we can look at. It's just a lot of bits on a video screen is all it is. It's computed. It's not a real thing. It's just a computed thing. So it has these three things going on. There's the player that makes all the choices. There's the server, or the computer, that serves up the virtual reality game. And then there's the game itself, which has the elf and all the players in it. So there's only two of those things are actually real. And that's the server and the player. And the server and player are in this dance of sending information back and forth. Right? So the player says, I want my player to run away quick. And he sends that to the server. The server then shows the player running away quick and has to calculate what that means. What are the consequences of running away quick? That's part of the rule set of the game that defines the World of Warcraft. You say, so now when we look at that from us, all right, if that's a virtual reality game, then what does that say about us? That says our body is the avatar. It's just eye candy. Our body is the avatar, and that our consciousness is the player making all the choices for the avatar, and that the player and the computer are all part of the same thing, because just like the player and the computer all have to be in the same reality in a video game because they're communicating with each other back and forth all the time. Well, we, the consciousness player, have to be in the same reality and of the same stuff as the computer, the server, which is consciousness. Consciousness is an information system. An information system can configure itself in the form of a computer, a server. It can also organize itself in terms of a consciousness, an individuated unit of consciousness. That's a player. So now the computer and the player are both different organizations, different subsets of the fundamental source stuff, which is consciousness. So that's kind of how I looked at it. And all that just kind of fell into place once I got this idea that consciousness was information. It was all about information systems. And that got to, and all that works out. And then I started realizing that, I can take that and I can understand quantum physics. I can understand, the speed of light, why it's a constant. These sorts of things all start coming out of that understanding. And then I started working on other things. Where does time come from? Where does, mass and charge, and where are all these in space? Where do they come from? And suddenly, click, 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 I had answers for all of those. Where did that ball of plasma come from? There's the answer. And how is it? And somebody would say, well, who programmed it then? If this is a virtual reality, who's the programmer? Is that God's the programmer? No, there is no programmer. It evolved. This is where evolution comes in. It just evolved. And we today in our computer science departments and universities do a similar thing. You take a rule set and a set of initial conditions, and you let it evolve. And those initial conditions will change according to the rule set, and you can evolve things. Well, we had a set of initial conditions. That was that ball of plasma, the initial conditions, very, very small space, very high pressure, very high temperature, and we have a rule set we call science, physics even. That's the rule set. So you start with a ball of plasma, you come up with a rule set, and you push the run button, and you let that ball of plasma change according to the rule set. And it evolves into planets and stars and, the universe and yada, yada, and here we are. So we are this avatar. So it evolved us as avatars. It evolved our biology out of a rule set and a set of initial conditions. And that gave consciousness something that could play. Now the players had a game they could play in. And why was that important? Because the whole point of an information system is to create more and better information. And we can call that lowering its entropy. This is a very central core idea here. So you have an information system, and if
let me go back just to ask one question about the Big Bang before we go into entropy. Okay. When it comes to that Big Bang, there were some inputs there that evolved over a long period of time.
Right.
I guess the obvious question for someone that doesn't know any better would be, where did those inputs come from?
Right. Well, that's a good question, and that's one of those paradoxes that we have here in physics. In physics, we have this paradox. I think it's I'm not sure of the proper name for it, but what it is that there are a set of constants that if the, kind of universal constants at the universe level, and if these constants were different, like gravitation is one of those constants. Yeah. So sure. If you have these constants, and if they change, even in the 9th or 10th decimal place, the whole universe wouldn't have evolved. It would have crashed and burned, it would go unstable. Everything has to be balanced. In a simulation like this, there's lots of things that just have to balance to end up with what we've got. So here we have this, I think it's the anthropomorphic principle or something like that is what it's called. But anyway, so we have this set of constants. And if you changed any one of them in a 10th decimal place, the whole universe wouldn't exist. It would have become unstable and gone away. Well, how does that happen? Well, that's easy. Okay, Big Bang, take one. We've got a rule set. We've got initial conditions. It goes a little while and it crashes. All right, let's adjust. Let's turn that gravity down a little bit. Let's do this. Let's adjust that. Big Bang, take two. And you keep doing that over and over, maybe thousands of times, maybe hundreds of thousands of times, trial and error, until you have this system, the rule set and the initial conditions, tuned to be stable over a very long period of time. That then tells us why we happen to have these constants all to many decimal places that have to be so critically accurate. Why? Because they evolved to be that way. So there's one of those paradoxes solved.
Could it be, though, that there really is a literal programmer outside of our reality, or do you think that is probably not likely the case?
No, that's not likely the case. Programming is very, very time-consuming and very, what can we say, not very adaptable. It just is what it is. It's much better to have what's now called procedural programming. Like I think the first big one out of the gate on that was called No Man's Sky. Okay, where in No Man's Sky, they have quintillions of planets and critters and fauna and all this stuff. And it's all computed on the fly, right? If you're there, whatever you're looking at, it computes that. And as soon as you look away, it stops computing that. It's all done with probability, random number generators and probability. So yes, it's got a rule set behind it, but there's all sorts of different things now can evolve out of that. So if you've got even just 10 or 20 variables in a game like that, how many possibilities can you get out of mixing 10 or 20 things? Well, it's trillions, quadrillions.
Mm.
So the number of possibilities of way things can go together are tremendous. So that is the way our reality is. Our reality is only generated in as much as what we look at. When we don't look at it, we're not getting a data stream. Remember, we, the player, get a data stream from the server, and that data stream defines the reality that we see. All right. So right now I'm seeing a bookcase behind you, and I'm getting data stream, and my consciousness is getting a data stream from the server that shows me a bookcase behind you. Your data stream doesn't have a bookcase in it because it's behind you. You see?
Right.
So right now, we think we have organs inside our body, that we need oxygen to breathe, that we have lungs, and we distribute, hemoglobin gets the oxygen, distributes it around through the cells, and so on. We think all that's, has to happen. It doesn't have to happen. Only when you have something that measures that oxygen, only when you look at it. In other words, the physical world is just the surface. So it doesn't have to what's it called? Render. It doesn't have to render a heart or lungs or a brain or an optic nerve. All it has to render for us is what looks like, as if you had a brain, as if you had a heart and lungs. So it has to render that, just like the elf. The elf doesn't have lungs and a brain, but if that elf goes underwater and stays too long, it drowns. Why? Lack of oxygen. Well, how's that possible? That elf is just a figment. How does it die? Because it doesn't have enough oxygen. Well, it's just the way the rule set's written. Our rule set is a very complex rule set that we call science, we call physics. And it's allowed this physical reality to be here, but our physical reality is just rendered. Everything physical is a rendering. So we're a piece of consciousness getting a data stream from this server, this larger consciousness system that's a server, and we see it as this. Just like we see that World of Warcraft as this, it's whatever we see it. There's rivers and rocks and trees and buildings and people, and the people speak to you and all of that, just like it is here. So you think that, 20, 30 years ago, we would have said, wow, that's just too much. Computers can't be that fast. Well, now we say they can. There's lots of visuals out there in virtual reality games that are very, very realistic. And then if they put you on a platform that bumps and moves and wiggles, and they put in smells and they put in things, spray water and do liquids, if you get the really, really highest tech stuff, it's really very hard to tell that from this, the virtual from the not virtual. It's really hard. So all you need is a computer that's just about as good as our computers now. So, we're talking about things that are basically billions of times faster and better than our computers are now. So the fact that it can do this is not impossible. Now, the fact that it is not a grounds up, you see, when people throw away the virtual reality possibility, they say it's just impossible. If you start with, elementary particles, you start with those, and then you take the quarks and you make, particles out of them, and then you make atoms out of the particles, and then you make molecules out of the atoms. And if you go through that and you say, and if you had to keep track of all of that, it's just too much. It's beyond the possibility.
Computation.
Yeah, the computation is impossible. Well, I agree with that. That's a ridiculous idea. It doesn't work that way. It works, World of Warcraft doesn't that way. That elf isn't built up of molecules. That elf is just pixels on a screen lit up. And so are we, you see. Now,
I have a question here. It's interesting because you were talking about how realistic videos or games are becoming. I was looking at a video not long ago on YouTube, and I thought I was watching like a video game recording, and I looked a little closer and I realized that it was actually a real life event that was playing out.
Yeah, I've done that before. Yeah, my grandson was in my house and playing a basketball he was watching this basketball game, and I'm walking, and he's doing, and I say, well, who's playing? And then, I realize he's going click, 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 click on his things, and I look at it again, and oh, yeah, that's not an actual basketball game that's being played,
right?
But it looked like it. Now once you realize it and you study it a little bit, you can see little bits and details, but those can be fixed with just more processor and a little and more detail. So yes, it's hard to tell the difference sometimes.
I want to ask you this, when it comes to these video games that have really, it's almost hard to believe what's become a video game since I was a child, when they were just very primitive dots on a screen and Pong and whatnot. But even as good as those things look, and even though they might trick you, if you look, you're not sure if you're seeing a video, it's still only a two-dimensional operation, right? It's just light on a screen, a flat screen, which is quite different than the actual world that we're experiencing, which is an actual literal 3D reality. So I wonder how it would be possible to actually make like a literal 3D reality, not just one where our sense experience is kind of tricking us into thinking it is, and how you would actually cause consciousness to happen inside that reality. And it just, I don't know. What do you think about what I just said?
You don't need that 3D reality. All you need is it needs to appear to be 3D to the player. If the player sees it as a 3D, then that's all you need. Anything else is unnecessary. I mean,
so would you say that our reality is only two-dimensional in some fundamental aspect then?
I wouldn't say that it's only two-dimensional, because I don't think we can limit it to dimensions. It's just our data stream is just no more than what we need in order to function in it, in order to interact. Okay, now we can interact in a virtual reality that is basically dots on a screen, because we see depth, we see rivers, we see trees blowing in the wind, we see people, fighting with their swords. We see all this stuff going on. We see it all in 3D. That's a 3D world. And we interact with it that way. We decide to run or fight or jump up and down or dance or do whatever we decide to do based on what we see. And that's all you need. You don't need any more than that. So we are given enough information that what we see, we interpret that as a 3D reality. It's our interpretation as consciousness. So consciousness sees a bunch of pixels on a screen, and consciousness interprets those pixels on a screen as rocks and rivers and people and trees and turtles. It just interprets them that way. All they are is dots of light on a screen. Matter of fact, they've only got three coordinates. They got a color, they got a position, and they got an intensity. That's it. And we take that data and then we interpret it to be a 3D landscape. That's all that's necessary. And as you turn and look around, and as you go other places, and as you look behind things and pick up rocks and look under them, it doesn't matter. It doesn't have to be anything that's 3D. All it has to be is data that we can interpret in terms of the 3D. And how do we learn to interpret the data that way? Well, we start when we are born, and we find out, this is mom, this is dad, that's an apple, this is my house, this is outside my house. And we start interpreting things. We don't know what anything is, but we learn. And we learn how to interpret and how it interacts and what it means to us. And we learn how to do that interpretation. So we get this data stream, we interpret it to be this reality, which brings us to a very interesting point. In a virtual reality, the virtual reality itself only exists in the minds of the players. Okay? When you're playing World of Warcraft, there is no place where there's a bunch of little elves and barbarians running around fighting each other. It only exists in the minds of the players. Okay? So if you want to put a new thing, if you want to say drive a Jeep through that, through that war that's going on, well, then that Jeep has to be in the mind of a player somewhere. The player who's looking at that space will get that data that defines that Jeep driving through there. Okay. So it only exists in the minds of the players. Now, what does that mean to us? If our reality only exists in the minds of the players, what that means to us is that until we make the measurement, we don't have a real particle, because a real particle only becomes real when some player gets the information. Then it becomes a part of the virtual reality. If we're calling the virtual reality the physical space, like it is to the elf, versus virtual reality is a physical space. Well, until that comes to a player, there is no particle. Mm-hmm. That data comes to that player now,
and that plays into quantum mechanical decoherence and everything.
That's it. That's what quantum. Well, that's why you have this thing called the observer paradox is what they call it. How come it is that you only get a particle when the measurement's made? Well, the measurement is the observation. Now, whether it's a tool making the observation or a human, doesn't make any difference. It's the information becomes available to a player. And whether that information is actually looked at by the player doesn't matter either. It's just available to the player. And that's why quantum physics works the way it works. That's why we have this magical, the wave function collapses to a physical particle when the measurement's made. And that doesn't make any sense, does it? But that's why, because nothing can come into this reality if it doesn't come in as information to a player. So the player's important. So there we've got that. What about this? What about the speed of light? Well, the speed of light is a constant because that's as fast as you can move a particle, a piece of mass, from one pixel to the next to the next. Mm-hmm. So we have like all simulations, there's a time clock. You cycle through time. That makes it a dynamic simulation. If you got motion, you have to see it's here now, and then it's there next time, it's there next time, it's there next time. Things move. That's called a dynamic situation where you have motion, things change. Well, there has to be a time loop. So you keep increasing time by delta t, go through the time loop, recompute everything. Now my finger's here. Next delta t, it's here. Next delta t, it's here. And if I have delta t small enough, then it looks like it's smooth. It looks like we see it. All right, so every simulation has an outside clock. So as fast as you can move something contiguously, not teleporting, jumping around teleporting, but contiguously through our space is one pixel at a time. So when you move, here's this delta t, it's here. This delta t, it's the next pixel. Next delta t, it's the next pixel. You can't move any faster than that. Mm-hmm. To go faster, you'd have to skip pixels. Well, it's here. Now I'm going to jump at 10. Well, that's teleporting. And that's not the kind of virtual reality we have. We have things that move contiguously, at least appear to move contiguously through space. So that's why speed of light's a constant, because that's as fast as you can move something through. And that means that we have a delta t and a delta x, right, for that pixel size. And if you take delta x divide by delta t, you get the speed of light. That's the fastest speed that things can go. Now, think about this. The delta t and delta x define the resolution of our virtual reality. And it's a fact that the speed of light seems to have changed a little bit out in the 8th or 9th decimal place over time. It gets just a tiny bigger. It gets just a tiny less. Now, not much, just way out there in that space. And that's another big paradox. How come? And this is not measurement error. It's changes that are bigger than the error of the measurement. So these are real changes in the speed of light. Tiny little changes. Now, why would that be? Well, if delta t and delta x represent the resolution, what if we need a little more resolution? Can we get that? Well, we just need to keep that ratio the same, because we don't want the speed of light to change, because there's a whole lot of things in physics that speed of light affects rather dramatically. So we're going to keep that the same. So what do? Well, we're going to try to change the delta t and the delta x by the same amount, right? We want them both so the ratio stays the same. So I'm going to make delta t twice as big and delta x twice as big, or half as big. So we do that. Now, we can't do that exactly because we're talking about pixels. So you can only change them to keep that ratio such that you can't change them to be anything you want. they have to change by a whole delta, by a whole pixel worth of delta t or a whole pixel worth of delta x.
And there has to be a constant of proportionality,
but
whichever way you go with it.
Right, but you can't make that proportion be exactly the same, because you can't split pixels into pieces. Because it's pixelated, you're going to get it as close as you can, but there's always going to be a little bit of misfit to it because it's pixelated. You can't divide pixels. So that's another one of those mysteries that now has a solution that we could do that. Now, why would they want to change resolution? Well, more resolution takes up more computation space. You shouldn't ever have more resolution in your model than you need, for whatever your users are. Well, we start digging deeper and deeper into things, then we need more and more resolution to support that. The system is not efficient if it delivers more resolution than actually the users need. So, of course, the resolution is going to change. As we dig deeper and deeper into our material reality, that's going to need more resolution. And what is that resolution now? We call that Planck time, Planck space, right?
Yeah.
So that's our best guess at what that resolution is right now. And, I don't know that that's really the case, but it's as close as we can come with our science right now, saying that's probably what those delta X and delta T's are. And that is the place where our reality becomes granular. So see, there's just, as you go through this, there's just so many paradoxes that just fall out as obvious. They're not hard to figure. So again, remind you, it's just a model. This is not Tom Campbell's belief in how the world is. It's a model. And if the model can explain things, then it's a good model. If the model can't explain things, it's not a good model. Or if the model can only explain this part of it, not that part, sort of like classical
relativity
mechanics,
or whatever.
or relativity or quantum mechanics. They only explain parts of it. So that's how you judge a model, is about how much it can, how much of the experimental evidence we have can be explained. And my model explains all the experimental evidence in both the objective world, the world that we call our material world, and the subjective world. It explains how remote viewing works, and how mental healing works, and how it is that mind can affect matter, and how it is that there's such a thing as touch typing, that your intuition can actually process that data without you thinking about it. And there's a lot of things that it just explains. And so far, and I have been looking, again, this is not what I believe. It's just the best model I could make up to fit all the facts. I've been looking since I put this model out there for things that disagree with it. And so far, every time I found something that appears to disagree, I look at it a little bit and, oh, yeah, okay, that's how it works. And it just falls right out, like, the speed of light being a constant. So that's the way it appears to work. Even chaos theory seems to fall out of the same, the same understanding. So far, I haven't found things that can't be explained logically by this model. So that's why I say that it seems to be a good model. Now, do I believe that it'll always be able to explain everything? No, probably not. That would be pretty. Hubris, pretty arrogant to think that, what is going to be true for all time. Goodness, there's lots of things we're going to discover, in the next decade, much less the next, 100,000 years. It's hard to imagine how much our knowledge will increase by then. But I think it's a good model so far. It's a pretty good model, at least worth looking at. And if anybody finds something that isn't easily explainable with the model, then I'll be the very first one that wants to know about it. And maybe that means the model has to change, or maybe the model, isn't. You have to look at the logic of the model. So I don't see my model as the truth and as perfection. I just see it as
fitting
a theory. I'm fitting data, And the more data it fits, then the better the model it is. So it's just that simple. Models have to grow and change. And all right, so that
Have you
kind of
done a
gives
lot
us
of
where we
work?
are.
Yeah, I want to ask you a question about information too, but have you done a lot of work as far as like writing papers and everything to try to convince the scientific community that you're on the right track? Or because I know you have some experiments that have kind of been, I don't know if you have done those experiments yet or not, but I know you've been trying to work toward like some concrete evidence to show the world that this is the right track to pursue.
Yeah. Of course, you can't. If you talk to the physics community, you have to talk with experiments. Anything else is just conjecture. Experiments define truth, and the rest is conjecture. Not that there's anything particularly wrong with conjecture. Conjecture is always where you start. That's how you get new paradigms. Is they start as conjecture, and then you build evidence underneath of them. So yes, I have a set of quantum physics experiments that I made up. I delivered them first in LA, California in 2016. I spent a day there just going over all of these experiments, and they're just straightforward quantum physics experiments. And what they do is they create evidence. Now, I have to emphasize evidence. Science doesn't talk about proof. Science used to talk about proof back in Newton's days. That's why we had Newton's laws. Well, we don't talk about, the law of quantum physics and the law of relativity because we learned a lesson. You don't know everything, and the future is liable to tell you that you're wrong if you think you know everything. So we talk about evidence, not, absolute truth. Absolute truth will work its way out as future people, discover more and more. So we have evidence. So I have these quantum experiments, and yes, I am doing them. And I'm hopefully, if everything goes great, we could maybe in a matter of a month or so have the first one done. And even if everything goes wrong, we're going to have them done, let's say, in 6 months from now. So they are being done. And after we do the first one, the second one will come in, the third and fourth. There's 5 of them, basically. And what they will do is create evidence that, one, this is a virtual reality. Again, another nail in that same coffin of materialism that says that this reality is information-based. It will also say that it'll also produce evidence that this reality is computed. It's a virtual reality, because we will be able to interact with the experiment in such a way as we change things, it changes things. Well, that's only possible if it isn't a machine. If it is aware of what we're doing and it changes as we change, if we can kind of see that, then we see that there's something else. It's not just a machine that we're talking to. There's rules and things that can change according to the way we change those rules. So,
like an algorithm.
Yeah, right. So the double slit did something that was kind of a minor miracle. It did something that was impossible, right? Single particles going through slits one at a time for no good reason distributed themselves in an interference pattern. Whereas Newton would say that's impossible because they had no exterior forces on them to make them do anything other than just go in a straight line and hit the screen behind the slit. But they didn't do that. They distributed themselves in an interference pattern. So that's when we realized that, materialism really wasn't the right answer. It's a good answer, just like Newtonian physics is a good answer, in a certain space, and materialism is a good answer in a certain space, but it's not the answer. There's something else going on there. So we have, let's see, where was I going with that thought? So these experiments will do things like that. They do things that are minor miracles, do things that are impossible. One of the miracles that they're going to do is that if you have a photon coming at what's called a beam splitter, sometimes they used to call these half-silvered mirrors, where the particle hits it and it has a 50-50 chance of reflecting or transmitting. Well, that is random. It's just a random way that light interacts with the atoms and the molecules of that material. And
Right.
In my experiment, the experimenter will say, the next photon is going to reflect. Now, the next one after that, that's going to reflect too. The next one is going to transmit, and he's going to be right. He's going to be able to predict what it's going to do.
That would be incredible.
Yeah,
to put that together like that.
Well, that's a little miracle, just like the particles rearranging themselves into an interference pattern. And another one I have is that you have a radioactive source, and we know radioactive source throw out particles. That's what radioactive means. It throws out stuff, right? So these particles come flying out of it. And we know that it's absolutely random what direction they come out. They don't, always come out to the left or right or front or back. They come out any which way from a radioactive source. It's uniform. It's random. And in one experiment I have, you'll be able to say, the next radioactive particle is going to come out on the left, and it'll come out on the left. And the next one's going to come out on the right, and it'll come out on the right. In other words, they'll be able to predict how they come out, which is impossible because that's just a random function of how atoms decay. So these little minor miracles, just like the double slit was a minor miracle, are going to help create evidence for the fact that, one, this is a virtual reality, or you can say it's an information-based virtual reality. It's a simulation, however you want to say it, and that consciousness is the computer. Because it has to do with consciousness changing things that makes the system come out to one side or the other, or to reflect or not reflect. So, and anyway, that's what these experiments, if they work, I'm a scientist, I don't know that they're going to work, but I set them up to, and see if they work. If they work, then they will add a couple of more pieces of evidence that we live in a virtual reality and that consciousness is the computer in that virtual reality. Now, it's not going to prove anything. Again, you don't get proof in science, you get evidence in science.
Let's say that the experiments work. They all work to the best of your expectations. What do you think that will do to the scientific community? Will they try to write that off like they've written off, similar experiments? Or do you think that could propel you to be like a leading scientist in the quantum mechanical field? What do you think will happen if those experiments, work right?
Well, I think in the beginning, they will probably be blown off because that's what happens. If you just look at the history of major paradigm shifts, the paradigm shift doesn't just happen on a dime. Like somebody says, oh, it really works this way. And then everybody goes, oh, you're right. It never works that way. Somebody says, we've been looking at it wrong all along. It works this way. And everybody says, you're crazy. So sure, you're going to get pushed back. That's the way it is. The world isn't flat, it's round. You're an idiot. Of course it's flat. If it was round, everybody would fall off on the other side.
Right.
Anyhow, of course there's going to be pushback immediately. But as I said earlier, truth in science eventually floats to the top. And the reason that we have clung so stubbornly to a materialist viewpoint is because we don't have any other logical thing to replace it with. There is no logical thing. The quantum physicists that created quantum physics, I'm talking about, Niels Bohr and Planck and Heisenberg and, all those guys who created it, they were very excited about, wow, we've got something new. This is a breakthrough, a whole new view of reality. It's not mass at all. This is probability, and it's telling us these big things. And we went from that kind of enthusiasm to nobody will ever know. It's impossible to tell. It's just a weird science. That's all. That's called denial. We got to the point we just denied it because nobody in the 100 years since Bohr and Planck and those guys were excited about it. It's been 100 years since they were excited. Nobody in that 100 years has ever said, well, here's an alternative. Here's a logical model of how reality works. That's why physicists now won't say it's a virtual reality. They'll say it's an information-based reality. Well, what is an information-based reality? That means information is computed, right? It's computed reality. Computed reality means it's a simulation, which means it's a virtual reality. So when you say it's an information-based reality, the only rational conclusion that you can come to after you make that statement is that it's a virtual reality. But because they have no scientific logical model that structures that in a way that it makes sense, then they're not going to say that. They're going to say it's a virtual reality, because then they just make themselves look stupid. Oh, what do you think all this is, this matter? Look, nothing in there, right? No brain unless you cut my head open. That's ridiculous. That's what they'll get. So they can't go there, but I will present them a model. So I think that, yes, push back, and eventually those experiments will be repeated. They'll say, really, let me do that. We'll see if that works. And they'll get the same thing. And then they'll have to take it more seriously. And eventually, as time goes on, it will rise to the top, because as of yet, there are no other competing answers. In other words, I'd be happy with a different answer. I just would like to have a model that explains things. And so far, this is the only model that can explain all the facts we know now, and a lot of the stuff we don't know. Settles the paradoxes. So I believe that it will probably grow. Now, maybe it'll be shown wrong. My model is mostly metaphorical. The larger conscious system's a metaphor for source. An individuated unit of consciousness is a metaphor for a piece of that larger consciousness system that can log on to a game. It's very metaphorical from my viewpoint, because I just made up pieces everywhere my model and consciousness had a function that had to happen. I created a piece and gave it a name for that function. So that's all my model is. It's something that I made up in order to create something that would explain the facts. So I don't claim that it's perfect, but it at least works and does explain all the facts better than the model we have now. So yes, I think eventually it'll be accepted. They'll say that, wow, big breakthrough in the nature, big paradigm shift. I mean, we've had big paradigm shifts before, flat Earth to round Earth. Earth is the center of the universe. To Earth is not the center of the universe. It's just a piece of a solar system, and the solar system is not the center of the universe either, and so on. We've had these paradigm shifts where we see things very differently. Back in the 1500s, it was known by the intelligence scientists, if we can call them scientists at that point, that the reason that the heavenly bodies went around the earth is that they were pushed by angels. And there's any number of books that shows an angel up there, pushing the moon across and pushing the stars across. And obviously, it's only logical that the earth is the center, because we see all those things come up in the east and they set in the west, and then they come up again in the east and set in the west. So it's only logical that they circle the earth. And we know for a fact that nothing moves if you don't push it. If there's no force pushing it, nothing moves. Well, these things are moving, so they must be pushed. Well, they couldn't be pushed by us. So what could they be pushed by? Well, something must be, some force that we don't understand. And let's call it angels, because the clergy like that. It's a good name. So you see, it was a very logical, it seemed very rational at the time. And to tell those people, oh, no, there's this invisible force that is at work called gravity. What force? And you can say, well, you can't tell them about space-time. That's going to not work at all. So you say, well, look, masses attract. All masses attract each other. And they say, well, here's a rock and here's a rock. I don't feel any attraction. Oh, it's so small that you can't tell. But it's moving all of these planets around, right? But it's so small that I can't tell. And it's a force that nobody can see or whatever. It's an invisible force doing all that. I'll stick with my angels, pushing this stuff around. That seems irrational. And the one other thing I would say is that because it's been 100 years since the first quantum physicists were enthusiastic about finding a whole new way of looking at reality, it's been 100 years with absolutely zero breakthrough. Quantum physics is still just called weird physics. They have no structure, no idea, no theory, no model that they can do anything other than materialism. They're stuck with that because it's the only thing that they know of. That's the last time they thought they understood what was going on, was back in Newton's day.
Mm-hmm.
So if the paradigm shift wasn't massive, if the paradigm shift required to explain it wasn't really far out, wasn't absolutely insane and crazy, it would have been discovered in 100 years with a lot of very good minds working on it. So this paradigm shift is one that is from inside our present paradigm, has to look absolutely ridiculous. If it didn't, it couldn't possibly be the truth. So anything that is going to solve this mystery and solve all these paradoxes is going to have to be really wacky sounding, just like the round earth was wacky sounding, just like gravity's probably wacky sounding in its time. It's going to have to be really bizarre, or it couldn't possibly be the truth. It was just a little smidgen. Oh, we've almost got it right. We just have to change just a little bit, and suddenly it'll become clear. No, we've had 100 years and we've gone nowhere. Zero in 100 years. That tells me that if it isn't really, really strange, it couldn't possibly be true. So virtual reality, this is just an avatar. We're pieces of consciousness, not physical bodies. That's strange enough to be true.
I have a few questions on meditation that I want to ask you before we end this interview, but I do want to ask one more kind of scientific question. When it comes to information, I'm curious what you would be describing in the most primitive sense. If we could scale all the way into, the smallest pixel that we could see of this reality, is that like a filament of consciousness, or what is it there that's the bedrock?
Okay, let's talk a little bit about information. Information is the bedrock. Consciousness is an information system. That's the fundamental thing. Now, information is different than data. Okay, now we tend to confuse that, and we tend to use both words. We mean data, we say information, and both. So we're not very precise in the way we think about that, but we should be more precise because they're two very different things. Information is significance. It's the meaning. It's the content. So let's take a book. If you take a book, and a book is obviously a physical thing. So it's got physical paper and physical ink. Okay, now that's obviously just material stuff. That ink is not information. The words are not information. The ink words. The meaning of those words, the content of that book, the significance of that book, what that book tells you, that's information. The ink and the paper, well, the paper is the medium. The ink is the symbols, okay? That's data. That's data. Now, data can be moved. You can put it in a book and you can send the book someplace else and they can read it. You can put it on a tape. You can put it on a hard drive. That's data. Puts on a hard drive. You need a consciousness for information. Information only exists in a consciousness. That book, without a consciousness, without anybody to read it, is just data. Somebody reads it and says, oh, look, it's a book about explaining how to catch fish or something. And they get it. They get the meaning and the significance of what to do. Then it becomes information. So the way we work, the way we interact is that consciousness can create information. So we've got this information. This is concepts, ideas, things we want to say. We have to convert that into data. That data then comes out in the way we modulate our voice. That data comes out in the way we write with a pen. We create data. Now that data we can move someplace else. Data can be transferred to another person. Now that other person, let's say somebody does that, you have information, you write it with a pencil, that puts it into data, which is handwriting in a particular language, which has all its own rules for that data. I get it. Now I have to look at that data and translate it into information. That's not an exact process. Now, the process of taking the information that's in your head and translate it into data is not an exact process. You may not have, your language may not have all the words and the meanings and the subtleties that you need to really get that idea across. You just do your best. So what you do has uncertainty in it. I get that data with its uncertainty, And I have to interpret it based on my knowledge base, my fears, my knowledge, my ignorance, my beliefs. So then I translate that data into information in my consciousness. You see? Now, that's flawed because my translation isn't going to be perfect because it was written in terms of your metaphors, and I got to translate it in terms of my metaphors. So there's all this uncertainty in this process, but you see it goes from data can be moved to another. Now, what's in my consciousness, I can't transfer. I can't give to you. You can never know how I feel. I can tell you, I can describe it, but my description is not the same as my feeling. That's again, my description is data. What I feel, okay, that's the content. That's me. So we have to separate those two. And information only exists in a consciousness and cannot be transferred. It has to be transferred in terms of information. So even mind to mind, if we have telepathic connection between, I put it in data, language, some kind of logical form, I send it to you, you get it, and you have to interpret it. So even when it's mind to mind, what's in my mind just doesn't get planted into what's in your mind. It has to go through this process. So that's the big difference. So consciousness is the fundamental thing. Information only happens in consciousness. It's an information system. Consciousness deals in information. And you can only share data and then interpret information. Then you can create what you interpret. You can create more information and send it on to somebody else. But there's lots of uncertainties in that sending and transmitting. That's why, for example, men are from Mars and women are from Venus, because we both interpret differently. Mm-hmm. Males and females have different interpretations of the same data. So anyway, that's to answer that question. That's a major understanding between the difference between information and data. And I would tell your readers, if they're interested, if you go to my YouTube site, mm-hmm. and I've got like 1,000 videos there. So it's like looking for a needle in a haystack if you're going through and looking for specific things. So I have two things that will help. One, for the science-minded, if you click on the thing that says, what is that? What's the word? Where you have a set of things that you look at. Playlist, got it. Playlist. If you click on playlist, then go to something that says science trilogy. And it's not just a trilogy anymore. It's got 4 or 5 things. And that's basically a distillation of MBT science, where I go through, where I try to explain people the science of MBT, as opposed to how it applies to the that's how it applies to the objective world, as opposed to the subjective part of it. So anyway, so there's a place for people to go. And the other thing, that if you go to my website and go look at video, you'll find a tool in which you can put in a query and you'll get stuff back that will give you, that'll search through those thousands of videos for your subject. So you don't have to search for them.
That's pretty neat tool. I like that. I just want to ask you one question about meditation before I kind of let you get the last word with the final question that I have for you. I'm at a point in my life now where I'm trying to grow in a lot of different ways. I have this book on writing things down. I'm journaling and everything. And I seem to be someone who is kind of maybe restless by nature, I think. And the actual question I have for you here is, meditation can cause discomfort. How does a beginner overcome that discomfort? What advice would you give to someone who has high anxiety levels and is a restless person? How can they get good at reaching a proper meditative state? And how can they evolve in such a way as to be able to meditate like you do?
Okay. Well, there's a whole bunch of questions in there, actually. Meditation does not have to be like classical meditation, a mantra or fixing your attention on your breathing or looking at a mandala, or it doesn't have to be any of those kinds of things. Meditation is basically about just experiencing yourself, experiencing your own consciousness. And the meditation is really good when you stop experiencing your sense data. In other words, it's the same thing that happens when you read a good book. When you sit down and read a really good book, you don't realize that there's people walking down and there's traffic in the streets. All that just disappears. It's just you and what's going on in the book. And somebody could come up and tap you on the shoulder, and you'd probably jump and get back in this reality. But you stop processing your sense data because you're involved in the book. Well, now this is the same thing. Meditation is like that, except there is no book. There is no story. It's just you being by yourself, with yourself, to the point that you let all of your sense data go, that you no longer are paying attention to what you feel, what you smell, what you taste, what you hear, what you see. So you close your eyes. Now you're not seeing so much. It's a little harder to close your ears, but a quiet place is usually better for people who are learning to meditate. A place that has minimal amounts of sense data. I guess the best place would be in one of those immersion sensory deprivation tanks. It almost takes your sense data away as you float in one of those tanks. Well, that puts you into a good meditation state. So the meditation doesn't have to be some kind of classical thing that you do. And the problem with that is that sometimes people who are very logically oriented, they're logical process people. Sometimes they call those left brain people. They deal in the world with logical process. This, then this, then this, therefore that. And their lives are run that way. Well, they will get into meditation with that intellect. All right, let's see. I got to close my eyes. Now I'm going to say my mantra. Now, I got to say it clearly. I need to relax. And their intellect is all the time trying to explain to them what are they doing and judging how well am I doing it. Oh, am I doing it well? Let's see. Do I feel this? Do I feel that? How many thoughts have come in, and you put them away, and they're constantly judging, constantly analyzing, constantly trying to follow the directions. And all of that is counterproductive. That makes your meditation ineffective. Meditation is not an intellectual exercise. You've got to get your intellect to sit down and be quiet and let you meditate. So that's the whole point of meditation, is getting out of your intellect into your intuition. That makes a successful meditation. So whether you do that with a mantra or with breath or listening to a particular piece of music or anything else is irrelevant. Those are all just techniques to help you get your intellect to sit down and be quiet. The mantra just works by giving you non-operative fluff to fill your head with, called the mantra. It's just some nonsense thing that you just keep turning around in your head, which keeps your head busy, so it's not thinking of other things. So it's that's the trick. Fills your head with a non-operative sound, and then that lets you let go. So it doesn't matter really that you can just sit and be still. You don't have to do anything. Just try to not be analyzing, judging, assessing. Am I doing it right? Is this right? Is this wrong? How do I know that I'm really meditating? All that stuff is counterproductive. Just be with yourself and be quiet and let your mind be blank. Don't let it wander. Don't let it start figuring out, what am I going to do tomorrow? And what do I have to know? I got to call so-and-so. And, don't go through all that. That's the intellect. Slicing and dicing and, doing analysis. Just be empty. So work on that. Now, people who happen to be very anxious or happen to be, ADD or otherwise on edge, need to be moving all the time, they'll have a especially difficult problem. But they can learn to let their sense data go, just like anybody else.
Just through repetition or?
Just through repetition. It will take them longer because they have to settle down. But even a person that's ADD does settle down, particularly if they're in a non-stimulating environment. So you have to find a very non-stimulating environment. And then you have to just let your mind just be with yourself. I am. I call that point consciousness. When you become a point of consciousness floating in a void, then you have no sensory input, and you're in the perfect Descartes moment of, I am. That's all. Nothing else. Nothing else going on. I just have an awareness that I exist. And when you're in that point consciousness, that's the best of all possible meditations. That's kind of the goal. But don't expect to get to the goal on day 2. It may take a lot of practice. So get into an environment that is non-stimulating. And like everybody, the longer you're in that environment, the more bored you get. The more bored you get, the better. The more you just relax and let it be. Oh, I'm going to be here for 20 minutes. And then like kids in the backseat of the car. Are we there yet? Yeah, is it 20 minutes up yet? You can ask that every 30 seconds. Is it 20 minutes up yet? 20 minutes up yet? You need to just let that go. And just with practice, even if you tend to be an ADD kind of person, you can get to the point that you are not processing or minimizing the processing. And maybe that's as far as you can get, is just to minimize the processing and make the processing things that are as non-operative as possible. Instead of trying to decide, how you should change your portfolio of investments, just like the mantra, just let a sound rattle around in your head, or a chant, some little phrase or something you say, and it doesn't have to make, it's better if it doesn't make any sense. Just something to do. Do that. If you can't sit still, find something inoperative to do. Many people meditate while they do stuff that they do automatically, like ladies who knit. When they sit there on the couch and they're knitting, that's a great meditation, because their hands, like touch typing, just move all by themselves. They know what they're doing. They don't have to look at each stitch. If they do, then they're not good at it yet. When they get good at it, it's just something they do. So you can find a meditation just while you're sanding wood, because you like doing woodwork kind of thing. So just sanding a board can be a meditation. You're doing something, but it's not operative. You're not really thinking about it. You're just doing it. People do almost anything routinely to where it's a routine. They get to the point that they do it intuitively, without thinking. I mean, how many times have you shown up in your driveway and then kind of blinked and said, how the hell did I get here? I don't remember driving home. Your mind wasn't there, but you drove home just fine. When you are processing on the intuitive side, not the intellectual side, that's it. You're there. And it doesn't matter whether you're driving a car or sanding a board or doing nothing, just sitting still. That is a successful meditation. So if you can't sit still, then do something, but do something that's sufficiently boring and repetitive that it doesn't stimulate thoughts. You see?
Yeah. I know some people, I plan on next week attending my first, class at this meditation center. I just wanted to get some instruction, but one of the things they do is they teach this walking meditation. And I almost thought that sounded dangerous to me, because if I could walk off a cliff or something with that. So I just don't know if that, maybe I'm just not thinking about it right. I don't know.
No, when you do that, and that to me would be a little harder, but maybe it'd be easier for some people. I mean, some people have to move. They can't, if they sit still, they start getting antsy. So for those people, then a walking meditation would be the right idea. If you can sit still, then it would probably be better to sit still. But what they're doing there, they're not going fully in the meditation state. They're splitting their mind. They are they're doing a split, and they'll have 80% of their mind paying in the meditation, 20% of their mind making sure they don't step in a hole, or do something dangerous, or run into people, or walk off a cliff. So they're parallel processing. So they have part of them meditating and part of them not. And that's the way that's done. There's always a part of you that's aware of where your feet are going and where you are. But that part is just functioning at an automatic level. That's why you do it enough that it becomes automatic, that you don't have to think about it. If you have to think about it, that's counterproductive. Meditating is not thinking. It's not thinking the right thoughts. It's not thinking at all. It's just letting your mind be and just existing without doing. So you can't do things to meditate. That's counterproductive. You got to stop doing things to meditate unless you're so antsy that you want a parallel process and you can do things like sand the board or walk, and you do that without thinking about it. It has to be intuitive, on the intuitive side. Because meditation, when you're in that point consciousness state, you're entirely in an intuitive state. Your intellect is non-operative at that point. You're just existing.
I'm really looking forward to getting further into meditation to the point where I realize I've actually developed some minimal skill. I think that's going to play out in some positive ways in my life. Everything from sleeping better at night to just being more on track. But it's something that I will stick with. Tom, I've got one more question for you. I appreciate you coming on. I was looking forward to it. You know, I enjoyed your book. And you will be back here not too far into the future to talk with Bernardo Kastrup. But I do want to ask you one question and let you take us out here. There are a lot of people out there that are, you know, searching for the truth. Maybe they're, you know, overcoming their materialistic ways, but there's a lot of bad information out there. There are fraudulent people, people that want to take advantage of people with the message that they have. What would you say to someone out there that has, you know, read the books and they watch these videos and they're compelled to continue searching, but they're just not sure where the truth lies?
Okay, I would tell them two things, two fundamental concepts that if they keep in mind, they'll be all right. The first is, if it's not your experience, it's not your truth. I've mentioned that already. So if it's not your truth, don't see that as a bad thing or that it's a problem, other than the fact that you should maybe be thinking about how can I make that part of my experience? If that, you know, if the truth of that is something I'd like to discover, then you have to make a plan to how are you going to discover it. Okay, so if you learn that things don't always fit in a I believe it or I disbelieve it. Disbelieving it is another belief. You believe that you disbelieve it, you know. So belief is the problem. Throw out your belief. Belief is a trap. It keeps you from seeing the bigger pictures. So believe nothing. The second thing is be open-minded. Let your mind open to all sorts of possibilities, but also be skeptical. You must be skeptical of everything. And when I say everything, that's everything you hear, everything you see, you know, everything you smell and touch, everything. Be skeptical of it. And the person you need to be most skeptical of is yourself. Okay, so you have to be skeptical. Nobody can lead you down the la-la path better than you can lead yourself down there. So you need to be skeptical. Everything. And if you have this mindset that things either have to be true or false, or true or not true, or you believe them or you don't believe them, you can't do that. You can't be open-minded. You can't be skeptical. All you do is jump to conclusions, and then you make that belief a fact in your mind. Matter of fact, that's what we think our belief, you know, that's what, you ask somebody, well, what are your beliefs? And generally they won't have many beliefs. And that's because all of their beliefs they see as facts. They believe it, it becomes a fact. You see, so we hardly ever think of, I believe this. It's just a belief of mine. We say, oh, I know this. This is knowledge of mine. So you need to avoid that trap of the belief. So you always be skeptical. So if you don't have the experience, if you've never remote viewed, if you've never, healed somebody with your mind, if you've never, had a telepathic connection with somebody, if you're not empathetic to where you can feel other people's feelings, if you've never experienced any of that, that's okay. You just haven't experienced it. But it doesn't mean that it's false because you haven't experienced it. It just means you haven't experienced it. So if you wonder whether it's true or false, then you're going to have to make a plan to experience it. There are lots of places you can go to learn how to remote view. I teach courses in doing all those things, all those paranormal things. They're not hard to learn. Anybody can do them. What's hard is to be able to do them how you want, when you want, and to be accurate and to be reliable. That takes a lot of practice. But just to do them, just to show yourself that it can be done, that's easy. It's not hard at all. So if you want to prove to yourself you can do those things, then you just take a course, that teaches you how to do it. I've got a course out there that's entirely, on your own. You just do it in your own time, in your own way. It's an at-home course if you like it. So, in any case, those are the things I would tell a person. You're growing, you're getting a lot of stuff. Yes, there's going to be all kinds of hustlers out there, all kinds of people trying to sell you whatever it is they've got, all sorts of pulls and tugs and pushes, because when you're not too grown up, you have ego and you have fear. And what we tend to do is manipulate others to be the way we want them, to take advantage of them, to get money out of their pocketbook, to have them do the kind of things we'd want them to do. And we tend to do that. So it's not just that happens occasionally. That's pretty endemic. Not always criminal or nasty. Sometimes it's not that. It's much more benign than that, but it's everywhere. So be skeptical. I'm probably the only lecturer who talks about my model, and at the end, you'll see, if you listen to any of my talks to people, you'll see at the end, I tell them, don't believe anything I've told you. If you believe it, that's not any big help to you. If all you do is believe it, what do you gain by that? Very little. If you disbelieve it, you gain even less, because now you won't even look at it. But don't believe it. Experience it. Check it out with your own experience, and keep things in a measure of probability. So instead of saying I must believe this or disbelieve it, say, well, this is possible. I've heard a lot about it. A lot of people claim to do remote viewing, and the CIA did it for a while. So I'll give it a 0.1 probability that it's real and not just some sort of scam. 0.1. All right, that's fine. Give it a 0.1. Now, find out about it, read about it, study it, try to do it, work on it. And that 0.1, if you succeed, will go up to 0.2, to 0.5, to 0.8. If you don't, it'll go down. It'll go to 0.01, maybe 0.001. That's okay. It doesn't matter. As long as you're open, you see, to finding out and experimenting and trying, as long as you don't get into a belief and say, I'm done. That's it. That's the answer. I'll never look at it again. That's a belief trap. So you should have on your little probability line almost no ones and almost no zeros. Everything should be in the middle and should be in play, movable, something that can go up and down in probability based on your own experience. And if you don't ever try to get much experience, then most of those things will just always, you won't make much progress with that. So another thing I typically say is that you have to learn to live gracefully with uncertainty. Many people can't live gracefully with uncertainty. They want to know. So they make something up and then they believe it, and then they believe that they know, and they're done. And that happens on all sides. There's not just one set of people do that. Everybody tends to do that. So that's my thing to people. Live gracefully with uncertainty. Keep everything out there open-minded, a possibility. Even if it's a 0.001, it's a possibility. Stay open-minded. Put very few things at zero. So that's the idea. And if you do that, you'll always grow. You'll always get to the right place if you can always stay open-minded and skeptical, and make sure that you don't take on somebody else's experience as your own fact. If you haven't experienced it, it's somebody else's fact, not yours.